Welcome back, everyone. We hope that your summers were as great as ours, or your winters for those of you who are in the Southern Hemisphere. And as we move into a new season globally, we're moving into a new season of Astronomy Cast.
Yeah, as we mentioned in the feed, we've taken a summer hiatus from June, July, and August, which is mostly Pamela's busy travel season. It's the conference season. I gotta click that. Okay, conference season. It's when we're moving around, and you were what, in Beijing? You were in Atlanta. You were in about 8 other places.
I've done Las Vegas. Let's see, where all have I been? Las Vegas, San Francisco, San Diego, uh, Chicago,
China.
Atlanta, China. Well,
Yeah.
going to Madrid in 2 weeks, so it's not like it's over, but
It's,
with
oh,
with your kids back in school, and hey, we have to celebrate. This, I think, is our seventh anniversary episode.
is this really? Wow, we've been doing
Yeah.
this for 7 years. I've lost track of time. It's timeless.
It's
Um,
the IAU. You and I started with the IAU.
when
So I
Pluto
guess
wasn't a
this is our
planet.
sixth
Yeah,
year. Yeah,
sixth
that
year.
we
Yeah,
just finished our 6th year. We're going into our 7th year. But we
and
started with the IAU, and now we're 2 IAUs later.
the other funny thing, of course, is that so much new technology has come out in Google Plus over the course of the last 3 months, couple of
Yeah.
months. We've been integrating it with the virtual star parties, but we haven't actually brought it back into Astronomy Cast, our live recording. So it's going to be a little rusty, I think, for us to get back up to speed. But hopefully, this first show will be good. Actually, it's our second show because last week we did a live show at DragonCon in Atlanta
Yes.
in front of a live studio audience, which was quite a treat. So. All right. Well, so I think we're going to, as always, we're going to be recording this episode as a live Google Plus Hangout. We'll start the recording part of the show in just a couple of seconds, and then do our normal show. It takes us about half an hour, and then when we're finished, we'll stick around. Feel free to throw zingers at Pamela
Please don't.
in the chat. So there's a couple of places that you can do that. So if you're watching this on the event page, you can post your question there, although that's not the best place because for some reason the events are not being scooped up, or the comments and questions on that event page are not being scooped up by the tool that we're using to keep track of all the comments. So it's probably the worst place to do it. You can use the hashtag AstronomyCast on Twitter if you want to ask us a question. You can, if you're on Google Plus and you're actually watching this from the Google Plus page, you can post a question there and we'll see it. Or if you're watching this on YouTube, you can post your questions and comments into the YouTube comments, and then again we'll be able to keep track of them. And so, if we make a mistake or if there's some topic during the show that you want to recommend to us, then by all means throw it in there, and I will steal your ideas for my own and make it sound like I was the one who asked the question. Maybe I'll give some credit, but
He's usually good about giving
I'm usually
credit.
pretty good about that. Yeah, but then once we wrap up the show, and then we'll be going for another 30 minutes or so, and then by all means feel free to ask us some questions. It'll be really fun. Um, okay, cool. I think that's all we need. Anything else in preparing for the show?
I
No.
think that's good. I'm going to apologize in advance. I They harvested the corn here, and that means
Right.
I am filled with corn smut, which my body is rejecting, and so this show is brought to you thanks to decongestants, antihistamines, and maybe my brain. We're not sure if it's here as well.
All right. Well, we'll find out if you're up to the task. Um, Okay, cool. All right, well, so I think I'm ready to press record. I'm no longer recording on my Mac. I'm now recording on my Linux box, so this could go badly, but it's a lot more integrated, a lot faster. I'm a lot happier, so go Linux. All right, so are you ready to press record?
I'm ready, and I'm now actually in the right window.
Yeah.
So I'm pressing record
I have
and
also pressed
realizing
record.
that I am in stereo.
Okay,
It had to happen.
go back
It's
to
the
mono.
first show of the season. I'm gonna make that mistake.
That should be a default. Why isn't that saved by
I don't know.
GarageBand?
Okay, I'm pressing record again,
I've also pressed
and
record.
it's happily recording in mono this time.
Okay, perfect. All right, let me find my intro. All right, here we go. Astronomy Cast, episode 271 for Monday, September 10th, 2012. Who does what in space and astronomy? Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville. Hey, Pamela, how you doing?
Hey Fraser, I'm doing well. It's fall here. We're back with the new season, and we're back with, well, it's not hay fever, but corn fever. So forgive the scratchy voice.
But this is the start of our seventh year doing this.
Yes, that was an amazing realization.
Our 6-year anniversary of recording. We were just mentioning this. We started our first show is about how Pluto lost its planethood, and that was 2 meetings of the International Astronomical Union ago.
So the next meeting's in Hawaii. That's going to mark that we've been doing this going into our 10th year. So I think we need to plan to be in Hawaii for the next meeting.
Oh, that'd be great. Yeah, Hawaii's pretty close to me, so that sounds good. China, where you just came back from, was pretty far. So thanks to everybody who sort of put up with us not recording shows over the summer break. We really needed to take that hiatus, and clearly I think this is going to be the trend in the future. So that's just keep that in mind. A little bit of announcement. One, I just want to remind everybody that we're recording these episodes of Astronomy Cast as a live Google Plus Hangout on air, so you can actually watch us recording. We've got about 50 people watching us right now, actually. So if you want to join us, you can just come to Google Plus, search for me or Pamela, and we'll create an event in advance, so you can actually sign up to the event. It'll go into your calendar. It's pretty cool. The other thing we're doing, of course, is that every Sunday night we do our virtual star party where we hook up a bunch of telescopes live on the internet and broadcast our view. And last night was pretty cool. We had Uranus and Neptune for the first time.
Yay, you pronounced it the way I pronounce it this time.
I know, I'm caving to your politically correct pronunciation of Uranus. Yeah, so we had that. That was amazing. Live, Neptune was sort of the plan, and then Mike Phillips brought in Uranus just,
and we had moons galore. It was really fabulous.
Yeah, pretty amazing. So we do that. And then the last thing, just to remind everyone, we actually have mountains of announcements and stuff, but I won't sort of overwhelm you this time. We're going to get back with the weekly Space Hangout starting on Thursdays at 10 a.m. Pacific. You do the math. And then...
don't forget, we also have the Wednesday Science Hours at 4 p.m.
Science Hour. So yeah, we're doing about 4 different kinds of programs every week. So if you want space and astronomy, lots of opportunity. So the other thing, just to remind everyone, is that we're going to be doing the Not the End of the World cruise at the end of the year, and I think the time for registering for that is starting to close down in a couple of weeks. So if you have any interest in joining us on a cruise to celebrate the fact that the world isn't going to end, and so we're actually going to go to the Mayan ruins and stand right at the point of apocalypse and watch other people's
it's
faces.
Not that expensive as far as cruises go, and it's completely family friendly. Fraser's kids are going to be there.
Yep.
And I plan to try and kidnap them to go to Disney World at one point.
Perfect. Wait a minute. It's not family friendly when you kidnap my children to go to Disneyland. Cool. Yeah. No. So I think it's going to be a lot of fun. So I really hope people, if you're interested in doing that and you want to join us, that would be great fun. All right, well, let's get on with... and so you can go to, I guess, astrosphere.org. Yeah, and there's a link there for the Not the End of the World cruise, and you can find out more information about it there. So
yeah,
check that out. All right. Okay, so let's get on with this then. So in the past, if you looked up into the sky, you were an astronomer, or I guess maybe an astrologer. But everything has gotten so complicated. Now we have astrophysicists and cosmologists, planetary geologists, and even exobiologists. So who does what, and how do they all interact with one another? And if you want to go into space research as a career, which one should you choose? So what are you, Pamela?
I'm an astronomer. I technically have an undergraduate degree in astrophysics and a PhD in astronomy.
Not an astrologer.
But most of what I do, no, I'm not an astrologer. Although I did take a class on astrology so that I could more effectively understand why they're not science.
Did you really?
Yeah, actually. So I kid you not, when I was at the University of Texas, the barn that I kept my horses at, our dressage instructor hired a high-level local astrology person to come in and give I want to say it was an 8-week course on astrology out of her home. It was taken very seriously. There was homework, the whole 9 yards. It was just like any university course you might sign up for, except it was astrology. So yeah, that was an interesting take on they don't actually understand what it means when Mercury is in retrograde.
But it wasn't a skeptical view of astrology, right?
No,
It
no, no,
was
no. This was for people who were seriously trying to learn how to cast horoscopes and understand. It was fascinating to get an inside view on not the science.
That's amazing. Okay. All right. So now specifically though, you're an astronomer, and
I'm an
so
astronomer.
uh, what kinds of, I guess, what does an astronomer do?
Well, so the first breakdown that we hit is astronomer versus astrophysicist. Astronomers are, at the most basic level, people who go out, look up, and their way of doing science is based on an observational view of the universe. So as an astronomer, it's perfectly valid for me to say, we see all these following trends, we still need to define the physics that makes these trends happen in the universe. Um, an astrophysicist comes at it from the mathematical side, where you're working up from the basic equations to try and match what the astronomers are observing. And then there's this mix in between where you're doing both.
So an astronomer, for example, then would be the one who's actually looking through the telescope night after night, or looking through the data, or
Looking through the
looking at the
data, we don't look through scopes anymore.
right, looking through the data sent back from the Hubble Space Telescope,
Yes.
and I guess their catchword would be something like, huh, that's interesting, or I
Yeah.
wonder what this is, or can we zoom in on this, right?
And questions get answered using data. And with an
Right,
astrophysicist, questions get answered using mathematics to explain,
right, and
hopefully explain. But astrophysicists can make predictions that, so astronomers, you look for trends and stuff, but an astrophysicist is where you build the theoretical model that then can often make predictions. So for instance, the solar neutrino problem, which has now been solved, was astronomers noted what the flux coming off of the sun was. We had a general understanding of how old the sun is, and um, it was the astrophysicists who built a model explaining, well, there's nuclear generation going on in the core of the sun. These are the reactions that are likely taking place. This should be producing neutrinos. And then, to add a new word, particle cosmologists started looking for, or in this case, particle astrophysicists started looking for those neutrinos coming off of the sun, found 1/3 of what they expected. Astrophysicists have to go back and try and figure out what's going on. But then it was the high energy physicists that actually figured out what was going on using new data. So it's an iterative process where you have the data gatherers, the modelers, and people who look up, people who look in machines. It all works together.
right. And so just to, I guess that's that interesting distinction, right? That you have an astrophysicist will make a prediction. They'll say, I wonder if the universe works like this.
Yes.
And then they'll sit down, they'll take the math that they already know, and they'll say to themselves, if the universe worked like this, then the math would look like that. And
Yes.
then you would see things in space that matched these predictions that I'm making right now. And then they hand that off to, say, an astronomer as a collaborator to say, next time you're in front of a telescope, check to see if, you notice, some dark area over there, or these galaxies moving towards those galaxies, or, whatever it is that they're looking for. I mean, is that sort of an accurate way to describe it?
Yeah, and sometimes you get people who do both. I'm pretty much strictly an astronomer, but I work with people who, Bill Keel down at the University of Texas, not University of Texas, sorry, Bill Keel, who's down at the University of Alabama, he recently did a whole series of observations of overlapping galaxies, and as light from a background star passes through, antihistamine-induced Astronomy Cast episode. Preston, please forgive me. That's our audio editor. As light from the background galaxy passes through the foreground galaxy, you can start to see where dust in that foreground galaxy is obscuring the light from the background galaxy. And you can do mathematical models of the distribution of material within that foreground galaxy that match the observed dimming that you see of the background galaxy. So that's combining our physical understanding with mathematical models to match the observations. And in this case, it's one person who's taking both the astronomical side and the astrophysical side of the problem in hand.
Right. And so then, I mean, I think, in science, you've got probably a very similar, structure between almost all the sciences. I'm sure you have in
Yeah.
chemistry. I don't know if you have, theoretical chemists and then match up with, production chemists and so on. But it's that same idea where you've got someone pushing the boundaries and the frontiers and making predictions, and other people doing a lot of observations. And as you said, sometimes it's the same person. So then what's a cosmologist?
So a cosmologist is someone who's looking at the universe as a whole. So this is where we start taking into consideration the entirety of the universe formed in the moment of the Big Bang. This produced the cosmic microwave background. This produced the initial ratios of hydrogen, helium, and trace elements that we see in the most chemically enriched gas clouds in the universe. So cosmologists are trying to build that big picture understanding. Astronomers are typically looking at stars, galaxies as smaller systems. So the cosmologist is trying to take everything and look at it together. And you end up with gray areas where you have observational cosmologists who are measuring the expansion and acceleration of our universe by doing supernova studies. You have particle cosmologists who are trying to understand the origins of the universe and how particle physics works using some of the world's accelerators. And then you have theoretical cosmologists. Well, they're the people who are predicting when we look in the cosmic microwave background, we're going to see this distribution of the sizes of the hot and cold spots.
So cosmologists are really just astronomers, but they're looking at one specific subset of the science. I'm sure they wouldn't like me to say that to them to their faces.
Well,
but
it's so what's interesting.
highly specialized astronomers.
it's when you consider your subset of data as we're looking at the entire forest rather than the trees and animals living in the trees, that's probably the best way to look at it is the cosmologists are the ones flying in the helicopter above the forest trying to get the big picture view, while the astronomers are the ones in the forest taking core samples of the trees, catching squirrels and seeing what type of squirrel they are. And so the astronomers are the ones looking at the smaller properties, and the cosmologists are the ones looking at the big picture.
Okay, so then what's a space scientist?
I love looking at business cards at conferences and seeing what bin people have chosen to put themselves in.
Why have you chosen this specific title for yourself?
Right. So space scientists are people who often work more in space flight, space exploration. They're the ones who are looking at not a planet, not a star, but how do we survive in that place between the planets, between the stars. So space scientists are often people who are working with NASA in manned and unmanned spaceflight to try and define things like, well, how do we deal with heating and cooling properties in space? How do we build solar sails? So it's a lot more of literally dealing with space rather than with a thing.
But they're not engineers.
They can be engineers. So a space scientist can be someone who does a lot of engineering, but consider someone who's studying, for instance, the Van Allen radiation belts. That's hardcore science, understanding the thermodynamics of moving back and forth between the hot and being in sunlight and being in shadow, exposure to the vacuum of space. All of these different things. And then you add in the people who study orbits. That's now celestial mechanics and orbital mechanics.
So would you be a celestial mechanic? Would that be your title? I've never seen that one before.
I'd be astronomer. No, a celestial
No.
mechanic.
Would a person who does that be a celestial mechanic or an orbital mechanic?
So an orbital mechanic. An orbital mechanic is the poor schmo who's tasked with calculating how do you get from Earth to Mars in a low energy orbit.
But will a person actually put that on their business card?
Yeah, totally.
Really? Orbital mechanic. Because that's got to just get the craziest questions, right? Like, can you fix my car? And you know?
It's I'm losing my voice. Sorry. Going to mute and cough. Preston, can you please edit this? I will survive this episode.
All right.
There's actually a lot of complexity to orbital mechanics, and one of the members of my original dissertation committee, but unfortunately he passed away before I finished my degree, was Victor Zebehay. And his daughter and I were friends, and she told the story of how he basically figured out how to solve the one special case of the three-body problem that is solvable, basically while sitting at dinner, and he suddenly starts playing with like the salt and pepper and ketchup on the table.
And making a mashed potato devil's tower in the middle of the table?
Not quite. He was much more of a moving object. So,
right, okay.
Yeah. So orbital mechanics, they're the folks that figure out how do you get things in stable orbits? How do you get them from point A to B? How do you prevent things from colliding? How do you figure out globular clusters? That's one of the most complicated orbital mechanics problems, because you have all these stars that end up interacting with one another, and over time, mathematical models show that globular clusters, due to orbital mechanics, beat like a beating heart. And then celestial mechanics are people who are figuring out, well, how are the stars passing one another? How do you take into consideration proper motions to do a lot of astrometry and stuff? But then you also have astrometrists who are the ones measuring everything. I'm just going to keep throwing titles.
Please do. I'll stop you every time I hear a new one. Astrometrist?
Yes.
Is that right?
Yes.
So if I say I am an astrometer?
Yes, I do astrometry.
I do astrometry. I am an astrometer, and that means I measure space.
You are the person who very precisely measures the location of things and helps define coordinate systems. So someone who does astronomy, for instance, figures out what are the precise stars that Hubble uses to maintain its guiding. How do we take two different catalogs in the radio and the optical and line them up precisely? So that it's a very important field to do, because we don't always have objects that give off light across all the different wavelengths. We use quasars for a lot of different things, because many quasars, not all, but many quasars, you can see them in the optical, you can see them in the radio. But then you have to get the X-ray stuff on the same system, and there's so many different wavelengths, and trying to line everything up is a challenge.
All right, so there's a few more titles here. We've got people who are various kinds of geologists.
Yes.
Right, and so you've got a regular geologist, and then you have a planetary geologist.
Yes.
And so what's the distinction there?
Well, so
isn't Earth a planet?
Earth is a planet.
Did that get decided in the IAU while you were in China, that Earth is no longer a planet?
Earth is still a planet. Okay. They did redefine the AU in ways that I'm still trying to figure out.
Right.
So
the astrometers would be interested in that, I think. Go ahead.
So, the geology, if you go to the American Geophysics Union out in San Francisco, it's this amazing meeting of people whose jobs vary from helping to efficiently figure out where is there oil under the ground, to how are the plates on the planet moving, to a volcanologist is a very specific type of geologist, to what are the comparative characteristics between plate tectonics on Earth versus something like Venus, where it seems like the entire surface doesn't move, but rather just reshuffles every once in a while. So at its core, a geologist is someone who studies the uh, surface and internal characteristics of a gravitationally bound solid body. So
Not
Earth,
necessarily a planet.
right. Now, gas giants aren't as much the purview of a geologist, but planetary scientists start getting involved when you start looking at gas giants, ice giants, and things like that. So
Asteroids,
that's its
comets,
core.
Kuiper belts, they're fine with all that, right?
Well, so then icy bodies, those are completely different again. So everything's complicated. Planetary
Okay. All right.
scientists,
Well, let's go back to then. So a planetary geologist, not a planetary scientist, because that's different.
yeah, planetary geologist is someone who's dealing with bodies that you can model using geological models. So plate tectonics, volcanology.
Yeah.
You end up using hydrodynamics to understand ice processes, water processes. Planetary scientist broadens that. So a planetary geologist it's like the Venn diagram overlap between geologist and planetary scientist. So a planetary scientist moves on to take on things like Jupiter and Saturn, Neptune, Uranus, all of these gas bodies that you can't model the same way, but meteorology starts to creep in and matter. Gas dynamics matters. There's so much to learn, and when you start trying to figure out what do you need to know to do a given theory, what it takes to understand how Jupiter's atmosphere works is radically different from what it takes to understand how is it that Vesta's shaped in this crazy Dr. Seuss way that it's shaped. And so it takes two different types of degrees, two different types of science to model and understand those two objects that we throw into the same book when we teach in 8th grade.
So then I guess the last step is the biologists.
Right. So now we're starting to add in things like astrobiology, which is the study of trying to understand how do you determine if there is life out there among the stars? What chemical signatures do you look for in the atmosphere? How would life throw a planet's atmosphere out of chemical equilibrium? What is
But isn't that like the strangest career to have when you think about it? Because an astrobiologist has no access to actual astrobiology yet. And so they can't study aliens, right? Because so far none have been discovered. And so they can only make predictions. I mean, I'd say they're astrophysicists. They are, they are the equivalent,
no,
which
they're
is that.
theoretical biologists is what I
That's
would
what I
call
mean.
them.
That's what I mean. They're the equivalent, right? They're theoretical biologists. They are saying, if you ever, here's what life might look like out in space. Go look for that, and then they hand
And
that off
that's
to them.
cool.
Absolutely. No. I'm not saying
Their
that they
entire
shouldn't
job is
exist.
what if.
I'm just
And
saying it must be a very strange job to have
well, and
trained in biology and then not have any examples to look at the thing you've been trained in, right?
well, they do a lot of work studying extremophiles here on the planet Earth and saying, okay, where on the Earth do we have this totally insane uh, chemical composition, set of conditions? Let's go look there for life and see if life can exist. And this is where we had Mono Lake, which is extremely rich in arsenic, was searched for life. This is where a lot of people go and look in hot springs. There's all of the work to look at underground lakes in Antarctica. Um, there's lots of places that we see as models for trying to understand what life could potentially look like on other worlds. And hopefully within our lifetime, we'll be able to start going out and exploring Titan and Europa and Mars and looking for, we don't expect to find major life, but we might find bacterial life out there in our own solar system.
So then I want to give you a couple of examples of things that people do, and you can kind of tell me what kind of a job title you would want to be able to
Okay.
do that. So what if you're studying the atmosphere of Jupiter?
Planetary scientist or meteorologist?
Is there a planetary meteorologist?
It's a specialty in planetary science. Just like studying variable stars is a specialty in astronomy.
What if you are examining the effects of long-term radiation on astronauts?
Uh, that is straight up biology or space scientist.
Not space medicine? An
Space
astro
medicine,
doctor?
yeah, that's true. Space medicine is a field. I forgot about that.
You're an astro doctor?
NASA needs doctors too.
Astrophysicist. No,
No,
astrophysician. I've decided it's an astrophysician.
that would be a great title.
Exactly. What about examining the environments right around black holes?
That's probably a cosmologist.
Cosmologist, but isn't that like big picture stuff?
They tend to throw black hole studying in with cosmology.
All right. And what about predicting what kind of a life people will have based on the year they were born and what constellation the sun was in?
That's not a science, but it's called astrology.
Oh, God, I almost had you. You took a course on it, so you know an awful lot about it. So cool. And so I guess the last question is that if you want to go into space and astronomy as a career, how early do you have to actually decide? I mean, do you become which of them are real that you do really need to sort of hunker down and start learning, say, astrophysics early on and decide? Or
It
which can you just change your business card and go, now I'm a astrophysician, right?
Well, so none of them can you really just change your business card. If you want to make a career change, it's possible to get into any of these fields later in life, but it gets harder the more theoretical and mathematically driven the field you're going into is. I've seen lots of people go back to college in their 30s and 40s and go on to have good careers in astronomy as people who dance on that line between astronomy and astrophysics. But when it comes to theoretical work, there's actually a lot of research that shows most people have their major breakthroughs before they're 30. And so that means you really need to get started in the field as a teenager. And that sounds kind of weird to say, but going into astronomy and getting into the top theoretical programs is such a highly competitive field that nowadays they're looking for people who've been publishing research papers as undergraduates. And when you start looking at that level of competition, I'm not top of our field. I'm a perfectly generic American-bred astronomer, but my high school job was reducing VLA data, working at Haystack Observatory and measuring Stokes parameters of T Tauri stars using Haystack data. My high school job, not high school, my college job, I was publishing papers working at Michigan State University in variable stars. It's this sort of starting very early background that unfortunately is necessary when there might only be 10 positions in the entire United States for what you want to do once you get your PhD.
Right. And so, for example, if you want to be a planetary geologist, you've got to focus on geology and then start incorporating that planetary geology pretty early on.
Yeah, and so
And go to the right school where
and
they
go to the
really
right
teach it.
schools. So while you can for the non-theoretical, and here planetary does count, you can go back to college in your 30s and 40s. You can get a job working in the field. The observational stuff is much easier to get into. When you start getting into the theoretical modeling, there's so much to learn because you have to know all of the observational science, you have to know all of the mathematics, and you have to be able to do the computer models. That's a lifetime of work to get there.
Right.
And so it depends on what you want to do, but there are ways later in life to become a professional in these fields as long as you're not trying to become Albert Einstein in these fields later in life.
And which one would you say is the hardest of all of them? Like, which is the
People
one
who
that
do
all...
theoretical magnetohydrodynamics.
So that would be a...
People who study magnetic
No, no, no.
fields,
What's the name? What's their name? Like if it had a business card.
a theoretical astrophysicist.
Not a theoretical
No,
magnetodynamicist.
magnetohydrodynamics is a subfield of astrophysics.
Right. But the one that if you showed them person's business card, they would just like, whoa.
People, I think, are most whoa, as you put it, involving theoretical cosmology, because
Yeah,
that's kind of the sexiest one. But the thing about theoretical cosmology is you're allowed to make stuff up because not all the theories are
that's
testable.
your
This is
job.
where, yeah, it's your job to make up stuff that can't be proven. What I love about theoretical astrophysics is it does generally lead to provable theories.
Yeah, yeah, they're forced to make predictions that can be tested.
Yeah, cosmology, you can make stuff up. It
Well,
just has
thank
to
you
be
very
based
much,
in math.
Pamela. It is great to be back recording with you again, and I look forward to a whole now new and exciting season of Astronomy Cast and all the other stuff that we're working on. So, thanks again, and we'll see you next week.
Sounds great, Fraser. Talk to you later. Now, don't go away. We're just pausing our recordings. We'll now take questions. And please be gentle. Don't throw the zingers this week because really, antihistamines plus decongestants leads to stupid Pamela, which is why
Uh,
we did.
no, throw the
Oh,
zingers. Come on, Pamela, throw the zingers. Zingers. Um,
I
let me just
thought
save
you
my recording
liked
here.
me, Fraser.
So just remember, if you want to ask questions for Pamela and me, I can answer some stuff. Then you can either ask your question on the event page, or on the Google Plus page where this has been embedded. You can ask your question on Twitter with the hashtag AstronomyCast, or you can ask your question on YouTube just in the comments there, and I'll be watching all of those locations and trying to capture them. It worked. It's saved. And now I'm going to export it just to be safe to the desktop. Come on. All right, pressure's off. Everything's safe.
Yay.
Yay. Okay, so let's have some questions here. Um, let's see. Orbital mechanics. So someone said orbital mechanic needs a big set of spanners. That is true.
What I love is we once actually took the time out to calculate how long a lever arm you would need to move the planet Earth. And so, yeah, an orbital mechanic would have the lever arm. Now, the only problem is finding a fulcrum.
But is that's that famous quote, right? Give me a lever long enough and I'll move the Earth.
Yeah, and back, I think it was in season one or season two, we actually, I remember doing the
Did the math.
calculations to figure
Yeah.
that out. Yeah.
Yeah. So I've got a couple of people mentioning that they're able to watch this in Germany now. So I don't know if anyone is actually in Germany. Uh, I know that they were blocking Hangouts on Air for a little while there.
Yeah,
I'm
it's
not.
now fixed.
It's been
Yeah,
fixed
Google
or
and the German government reached a consensus something or other so that Google Hangouts on Air are now allowed to be broadcast in Germany.
oh, that's good because that's ridiculous. Someone wanted to know what version of Linux I'm using. So I'm using Ubuntu,
And
and
we
I
use
love it.
Ubuntu for everything for
Yeah.
Cosmic Quest.
Yeah, so I've been using
It's
various
my
versions
go-to.
of Ubuntu and keep trying to make it be my permanent desktop environment, and it never was. It was always just too complicated to get it perfectly working with everything. But the newest version, I guess, what 12, is
Yeah.
right out of the box, works like a charm. I haven't had to do a lot of customization, but it's still, if I want to do customizations, I can. So, I would highly recommend if anyone wants to try and get away from the Mac, Windows world, Linux as a desktop environment is actually ready for prime time, I think.
Yeah, I'm a lamp stack kind of girl myself.
Yeah. Yeah, again, people don't realize I'm the one with the computer science degree, and Pamela's the one that does all our coding. So, how did that happen? Um,
I don't know. I'm going to drag you back to the programming.
so Insider, yeah, I will. I want to. Insider has mentioned there is aerospace medicine. Some specialties can include so there's the Institute of Aerospace Medicine.
Oh, cool. Where's that?
Yeah, in Germany.
Mm,
That was from Insider. So I guess yeah. I mean, as humans spend more and more time out in space and eventually begin exploring the solar system, you're going to get this situation where everything is in space, right? You're
yeah.
a farmer in space, right?
Astro agriculture? What
Astroagriculture,
did they
yeah.
call it in The Moon is a Harsh Mistress?
They had farmers on the moon.
Yeah.
I don't know.
Okay. Anyways, thought for another day. One of my favorite terms that uh, isn't actually getting used, and that made me sad, was in some science fiction. There's the phrase xenobiology, which is biologists who study life on other worlds, but it ended up becoming astrobiology instead of xenobiology. And
Well,
I thought
I called
that
it
was way better.
exobiology in this, but I guess it is astrobiology.
It is astro. Yeah.
So Eric Pape wants to know, off topic, silly question: are the stars which are visible in the night sky only stars that are in our galaxy?
Yes. In fact, if you go outside in the northern hemisphere, if you have good eyes, not great eyes, good eyes, the only object that you can see in the entire sky that isn't in our galaxy is Andromeda. If you're in the southern hemisphere, you have the Large and Small Magellanic Clouds. If you have great eyes, there's a few additional Messier objects that start to become visible, but you have to be in a perfect sight and be slightly superhuman. But there are folks like Steve O'Meara who are able to be slightly superhuman, and things like M51 start to sneak into view.
Right, but essentially Andromeda is the most distant object that we can see with our unaided eyes as a
Normal humans, yes.
normal humans. Yeah, what is it? It's about 2.5 million light years away.
The light from it was originated about the same time that early two-legged our human ancestors started walking around
Right,
on the
the
earth.
first hominids. Yeah,
Yeah.
that's amazing. So yeah, so all those stars that you see, all of the clouds, all of the everything, that's all in our galaxy. It's all just part of the Milky Way, and just only Andromeda, that one thing, and I guess the large and small Magellanic Clouds. Um, is your or do you want to know
What?
if your sun sign or your rising sign is more important in casting your birth chart?
The sun sign.
The sun sign is more important in casting your nonsense birth chart.
Yes.
Okay, good. All right. Bridget Sheeran found this passage during an exam revision and would like you to put it into something a little more explainable. So here we go. You might not want to read it, but let's see. Spontaneous production of particle-antiparticle pairs close to the black hole can cause it to lose mass. If one particle falls into the black hole and the other escapes, the mass and energy of the escaping particle are lost by the black hole. So could you explain that in more
Yeah.
simply? That's Hawking
Yeah.
radiation, right?
Right, right. So this is the idea that black holes, if they're sufficiently large, if they're sufficiently small, are able to evaporate. And the reason large ones can't evaporate is because the flux of just like cosmic microwave background radiation falling into the black hole is sufficient to feed it at the same rate or faster than it's evaporating. But with particularly small black holes that don't have a very large event horizon, stuff isn't falling in as fast as it's evaporating. So if you imagine that my microphone is the Schwarzschild radius, the point at which your velocity has to be equal to or greater than the speed of light in order for you to escape the black hole's gravitational force. If at that Schwarzschild radius, the energy that's just permeating space creates a particle and an antiparticle on opposite sides of the Schwarzschild radius. If the black hole's over here, then the particle that's created on this side is going to end up being trapped inside the Schwarzschild radius. The particle that's created outside has the chance, because they'll be created with opposite velocities, has the chance to fly away, carrying its mass energy away with it. So this is one of those times when you have to remember, energy and mass are just two sides of the exact same thing. And energy has the ability to spontaneously and generally very temporarily turn itself into particles. And if those particles are on opposite sides of the Schwarzschild radius, the energy here turns into two particles that have opposite velocities to conserve energy and momentum. They fly away. This one stays within the Schwarzschild radius. This one goes off into space as Hawking radiation.
And the crazy part, though, is that actually causes the black hole itself to evaporate a little bit.
And over time, micro black holes, actually, we don't think that there should be any left floating around at the smallest scales in the universe, because they would have evaporated by now if they formed, as some predictions have them forming, during the early parts of the universe formation.
Right, you can imagine with very small black holes, there's lots of chances for that particle to be outside and able to move in any direction that it's going to be able to get away from the black hole. But on the big ones, the supermassive black holes, almost any direction and almost any speed that these virtual particles are going, they're just going to get gobbled back up by the black hole again.
Well,
So,
that's actually not the problem. It's the exact same. They have a chance to fly away, but the problem is that the supermassive black hole, it's big, and so materials falling into it over a much larger surface area. And so while the evaporation is taking place, the evaporation is at a lower rate than stuff coming in. So if you're leaking slower than stuff is coming in, you keep filling up rather than emptying out.
got it. Okay. Um, all right. So I've got a question here from David Bood. On September 14th, asteroid 2012, QG42 will pass between the Earth and the Moon. How close will it come? Um,
I
and I
don't
don't
know
know
the
exactly,
Yeah, so
but
Astronomers
just
Without Borders has information up on their site about this. We're safe. We're not in trouble. No satellites are currently predicted to lose their lives over this. Asteroids on a fairly regular basis come that
yeah.
close to Earth.
Yeah, I mean, just in general, I mean, I think it's important to just say that in general, this happens a lot. That,
Yeah,
I would say a few times a year we'll report on this on Universe Today and say, yeah, this asteroid is going to pass within the Earth Moon radius. And sometimes you get situations where the asteroid comes so close it's passing below the geostationary satellites. So
yeah.
so this is a fairly common situation and nothing to worry about. The position of all these asteroids have been charted out for decades in advance, and astronomers keep a list of which are the actual dangerous ones. So I think
There's
so.
there's a great Twitter feed called
Oh, what's that?
there's a great Twitter feed called Low Flying Rocks that actually tweets out about these different things as the rocks zip by.
Perfect. So there you go, low flying rocks. But yeah, so in just general, never panic unless we tell you to panic, and we have never told anybody to panic. But I promise that if there was a reason to panic, we would tell you. Nicole is saying that the characters in The Moon is a Harsh Mistress, they were called loonies, but I don't know if that's what you're looking for.
Yeah, I was looking specifically for the name of so they're farmers, and I'm trying to remember if they gave the farmers a specific name. Um, there's people who are non-farmers in Moon is a Harsh Mistress as well. The lead character, for instance, is an engineer who maintains the computers. But go read the book if you haven't. It's an absolutely fabulous science fiction book that also has some neat social implications in it as
I
well.
I
But
love yeah, I love those old Robert Heinlein
yeah,
books. They're great.
some of
I'm
his
gonna get
books are more sociology than
yeah.
science fiction. Moon is a Harsh Mistress is one of the ones that's much more science than sociology.
So Thomas Tranneker is asking, looking at the Vesta pictures, I see some lava flow on the surface and dark albedo. Is this signs of volcanism? So this is right. The NASA's Dawn spacecraft was at Vesta and had been doing tons of observations of Vesta, and now is just recently we actually just celebrated it leaving Vesta, and now it's on its way to Ceres. So so what do you think? Have astronomers are they seeing signs of volcanism on the surface of Vesta?
It's not so much volcanism as we're seeing different levels of the rocks being exposed. So it turns out that Vesta, despite being a not perfectly spherical rock, so it's not even quite big enough to be in complete hydrodynamic equilibrium. It's close, just not quite there. It during its formation process, just like a planet does, it differentiated itself into different layers. Now over time it's got pretty beat up, and it's now turning out that a lot of the meteorites that hit Earth probably originated from something hitting Vesta, shards being thrown out, and those shards came and landed on our planet. And during these various impacts, during these different events, it revealed these different layers of materials within Vesta.
Um, all right. Let me see. So Dennis wants to know, can you name any known amateur astronomers who contributed to astronomy in the history of science, um, or the history of astronomy?
Yes.
Um,
Grota Reba, did the early radio maps of the sky.
Yeah.
He built a very large, beautiful radio astronomy dish in his backyard. He was a commercial radio engineer, and he took his technology knowledge from commercial radio and built receivers that they created these amazing catalogs, and the astronomers who were trying to peer review the journal articles he submitted actually showed up at his doorstep to check out his setup, and they verified everything was correct. William Herschel was in many ways a citizen scientist. He was trained as a composer, oboist, orchestra conductor, and went on to discover Uranus, Saturn's nebula, thousands of objects, a large number of comets and asteroids. His work formed the basis, along with his sister Carolyn's work, of the new general catalog of objects, NGC numbers that we still use today. There was Milton Humison. Milton Humison was a mule cart driver who went on to work with Hubble at Mount Wilson Observatory. There was Leslie Peltier, who contributed over 100,000 observations to the American Association of Variable Star Observers, discovered, I think, 22 comets. That number could be wrong, but I could just keep going.
You know what? This is starting to sound like a show, Pamela.
Yeah.
Why don't we do an episode on amateur contributions to astronomy?
Okay.
That'd be good. I like that. And Nicole is mentioning Jeff Metcalf, who actually we just did the Star Party in Atlanta. He passed away from leukemia about 5 years ago.
Yeah.
And he's actually the person who named an asteroid after me and Phil. So Jeff Metcalf, and he discovered tons and tons of asteroids and named them after people. Tobitej wants to know when there's going to be another Weekly Space Hangout. We're going to do one on Thursday, so we're back with those as well. So we'll be doing the Weekly Space Hangouts as well. Every Thursday, 10 a.m. Pacific, 1 Eastern, some other time zones. Let me see. Any other questions here? So now here's one so I don't know if you've seen this or have been watching this. Have you heard of the Mystery Dark at all, Pamela?
No.
No? So this was from Mikhail Levonimi. He was sort of linking to a Phys.org article, and I'm not sure if we can do it, but the Mystery Dark. So I guess if you had heard of it, but
No, I haven't.
No? Okay, all right. Well, we'll take a look at that and then maybe bring that back as an interesting show or something. Craig Simmons asks, what is the universe expanding into? And we've actually got a whole episode of Astronomy Cast fairly early on called What is the Universe Expanding Into? And so, check that out. We've actually got the episode. So just Google that. What is the universe expanding into, Astronomy Cast, and that'll take you to that episode.
And the summary is invalid by our understanding of the geometry.
Right.
Invalid question.
That is a nonsense question. That everything that is the universe.
It's sort of like asking, where is the edge of the surface of a balloon?
Right. There is no edge. That's a crazy question. So it's hard because you really expect it, but it's not.
Yeah.
So have you heard that people are calling this cruise we're doing? They're calling it Cruiseageddon.
No, that's awesome.
Isn't that great?
Join us. We're gonna have fun.
Yeah. So DMG 003 wants to know if Phil's going to be on the cruise. He's not.
No.
So this time around. But, this is really an experiment. We want to sort of see if this works. We've got invited the last minute onto this cruise, and so we're going to be participating and try to eke out a little bit of an Astronomy Cast part of the cruise itself. And then if this really works and we have a lot of fun and people are really interested in it, then I think we'll try and do more stuff like this. I personally think the best place to go would be like Hawaii, where we could go up to the observatories and pull all our strings to get access to some really cool observing places and see some volcanoes and stuff. So I think that would be cool.
And it's worth noting, if you do sign up for the cruise, hint, hint, we want to go play with you in foreign places.
Yeah.
When you talk to Zelda, who's the travel agent we're working with, I love that her name is Zelda.
It is Zelda, yeah. You should do her horoscope for her. Maybe she could do our horoscopes.
No. Make sure that you tell Zelda that you're going with Astronomy Cast so that we can get you on our list, so that you can be part of the special things that Fraser and I plan.
Um, oh, that's a good question. So bsimp07 wants to know what's the best place to go on a honeymoon that ties in with astronomy.
Um,
Where would you go? So you can't have an event, right? So you can't do like an eclipse or a
so
or
I'm thinking do something with the northern lights in the winter. That would be
oh
pretty romantic
yeah,
because it's nice and cold and you have all the excuses to curl up in front of a fireplace.
yeah,
And you're hearing the wishes of someone who has horrible hay fever and wants all plants dead at the moment.
right. Kill them
So,
all.
kill
Yeah,
all the plants.
right.
So
But
you have
go to an Arctic wasteland. That would work too.
yeah, a beautiful
Yeah.
Arctic wasteland with the winter skies and northern lights and yeah.
Yeah, there are some really interesting tours that they do out of Finland and also out of Alaska, where they'll take you to places that are fairly good for observing auroras, and then set you up a cabin and you can watch and teach you how to look for them, and
Yeah.
they'll even go to some really good spots. So I think that sounds like a great idea. Wow. Um, because I'm thinking other things like meteor showers. It's also
Well, so
time
other than
dependent, right?
that, McDonald Observatory, you can reserve the 82-inch telescope. And so it's West Texas, so it's not the most romantic site in the world. It's kind of dusty, dirty, Wild West. But if you like horses and like learning about the old lore of the Indians in the area, that can be pretty cool. So reserving a night on the 82-inch. There's a variety of other places that also allow amateur astronomers to get telescope time. So that's something else to look into.
And I've heard there are a few bed and breakfasts, and you can just do a Google search for this. There's some bed and breakfasts where, you know, they've got a telescope, like a really
Yeah.
nice telescope on site as well. And so you can go, you can stay in the place and also use their nice telescopes. So it's a pretty cool way to go. Um, let's see. Oh, it's gonna be in June. Yeah, well, you can see
So
the Northern Lights. Well, you can't see the Northern Lights in
no.
June.
Yeah, no, Northern Lights best in March and October, depending on hemisphere,
Yeah.
and replace the word northern with southern as necessary. For June, I'm assuming you mean 11 months from now, so I'd definitely try something like reserving the McDonald Observatory 82-inch, or look for some observational site. Australia actually has some amazing astrotourism in terms of going out to places that have observatories in dark skies.
So are we expecting to have annual Armageddons? Yeah, I guess Ryan Consul wants to note that this is very special because it's Armageddon, and so are we
Yeah,
going to have to fake an Armageddon every year
no.
so that we can have a cruise? I don't know.
No, we'll find other excuses. We're good at that.
Yeah, no problem. Um, okay, cool. Well, I think we're starting to run out of time. Let's take a couple more questions here and then wrap it up. Oh, sorry, I got so many windows now. I'm looking all over the place. Let me see if I got any more. No, I think we're good. Okay, here we
Okay.
go. So are we sure that there are no planet-like objects beyond the Kuiper Belt? This
No,
comes from Tobitej, and
no,
so
we aren't
no.
sure.
I
There's
would say
actually
almost it's almost the opposite, which is that there almost certainly is big
well, so
stuff
so
out
it
there.
depends on who you're talking about when it comes to defining planets. That gets tricky,
Yeah.
because there are folks that want to reclassify Ceres and Pluto and many of these other orbiting the sun large objects as planets again, and increase the number of planets to a very large number. But if you go by the current IAU definition of is there something large enough to have cleared its orbit, there are some really neat models that say the reason that we have this sudden observed drop off in number of icy objects out at, I think, 55 AU, but I may not have that number quite right. They predict that drop off is actually due to there being a larger object out in the outer solar system.
Right. And so this is one of those situations where it's sort of a math problem, right? That
Yeah.
that the further out you go, there's almost certainly objects which are larger than Pluto, larger than Eris. As you go, this mathematically, the universe or space is really big. The solar system is really big. The Oort cloud is really big and really hard to see. So,
Yeah.
yeah, it's just a matter of getting better and better instruments. I talked to Mike Brown about this about a year ago or so, and talking to him about how are there a lot of other large objects out there? And because there was this big flurry of discovery, and he said, well, what happened was we changed our techniques, we looked in different places, we got access to new technology, and so we got all of these discoveries all in really rapid fire succession. But it's going to take another jump in technology to uncover the next class of objects further out that are more distant and perhaps fainter. So we're
Yeah.
going to be in a bit of a break until, I guess, the James Webb shows up, and then there's
And
going to be a
and
whole new tool that's going to pop out a bunch more objects, and some of them could very well be larger than Pluto. Probably not
and
as big as the Earth, but
and one interesting point that I heard someone make was a lot of these brown dwarfs that are being found, they're so hard to observe that we don't have clear distances on them. And it's possible that there are brown dwarfs out there that are close enough to gravitationally currently be interacting with our sun, perhaps even a sister star that we don't know about, just because they're recently discovered and they're so hard to observe that we can't tell quite where they are and if they're moving in an orbital kind of way yet.
yeah. Okay, cool. All right. So, Craig, you just asked about the answer to the question. I just posted a link into the event page. So I just gave you a link to episode 28 of Astronomy Cast, where we answered what is the universe expanding into. So cool. Well, I think we'll wrap this up then. So thanks to everybody. Thank you very much, Pamela, for joining us. And it's great to be back in the seat again and recording episodes of Astronomy Cast. And lots of other great stuff coming up. So by all means, we'll see you. I don't know what's the next thing then? Wednesday?
The next thing is Wednesday, 4
Yeah.
p.m. Pacific, the weekly space hangout, and then we have Thursday morning, 10 a.m. Pacific. Sorry, I goofed the names on that.
Yeah, no.
Wednesday is Science Hour, Thursday is the space hangout, and then Sunday night is the virtual star party. And I think that's it for this week, but I think
Yes.
that's enough.
Perfect.
And one final plug, if you're interested in seeing a commercial company come into existence that uses its profits to fund space exploration, check out the Indiegogo Uwingu campaign. We have a few days left, and we still have $35,000 we're trying to raise.
6 days left.
Yeah.
Yeah. Cool. So yeah, Uwingu. Uwingu. Uwingu.
Yes.
Which is Swahili for sky. And
Yeah.
this is, you're involved, I'm involved,
Phil Plate's
Howard
involved.
Stern is involved. There's lots of great people involved in this, so check it out. Let's raise money for space. Cool. All right, well, why don't we wrap this up? So thanks again, Pamela, and we'll see everybody next week.
Okay, see you later. Bye-bye.